Now, let's take a closer look at the Q170 MCPU standalone motion controller settings for a multi-head labeling machine. Here you can see the I/O assignment for the controller, where input and output relay modules are configured to be used within a 2-slot extension rack. Note that this setup is not necessary for a single-axis labeling machine. Also take note that the Q170 MCPU is actually an 8-slot rack, which means that 7 slots are unoccupied and are configured as 0 points within the I/O settings. Another nice feature of this solution is that the program included for the Q170 MCPU falls into a format that can be easily converted to be used with the MR-MQ100 single-axis motion controller for a single-head labeling machine. The mechanical editor setup for this program illustrates virtual mode programming, where pulses from the incremental encoder connected to the conveyor enter the system through the drive module. An electronic virtual clutch is used to engage the servo based on the product's position. This opens and closes with on and off addresses. Motion is transferred through the clutch to the electronic virtual cam servo axis. This is the actual servo motor on the machine. In this application, the servo is set up as a feed cam in order to follow the encoder 1-to-1. An electronic virtual auxiliary servo motor is used to advance the web when missing labels are detected. To put all of this into perspective, let's take a look at how each of the physical components on the machine tie into the machine's virtual environment. The incremental encoder is connected to the encoder, which tracks the position of the conveyor. The photoelectric sensors provide registration or mark detection signals to the Q170 MCPU in order to control the on and off addresses of the electronic clutch. These can be viewed as indirectly controlling the electronic clutch. The servo motor can be shown linked to the output module, or the cam axis in this case. The next step is to configure the photoelectric mark sensor settings. This can be done through MTWorks 2 using the mark detection settings screen. For simplicity, the program has been set up to use registration for both the product and label sensors, assuming that 1 or 2 label heads are used. The product sensor is configured with the first input, DI1. The label sensor is configured to use the second input, DI2. For 3 or 4 label heads, it makes sense to configure 3 or 4 mark detection settings for the sensors on each of the label heads. The input module on the extension base would track the product position in this case. The program for this application solution includes a convenient routine to automatically detect the label pitch, which is the distance from the front edge of one label to the front edge of the next label. This function can be used to change over label reels with different size labels quickly and easily. This label pitch distance is used later in the program to detect for missing labels. Establishing an accurate label pitch also helps to define a stop distance for the label web to stop for accurate placement on the products. Also included is a web advance function that advances the label web when 1 or 2 labels are missing. If 3 or more labels are missing, the machine operation is stopped, and an error is flagged that it can be adjusted by the operator. This SFC program commands the virtual auxiliary servo motor to advance the label web at very high speeds when labels are missing, so that the web can be ready for the next clutch on address, which comes from the entering product. In other words, the web is advanced in time so the next label doesn't miss the next product. An exciting part of this solution includes the connection of a Cognex Insight Vision system directly to the Q170 MCPU standalone motion controller's built-in Ethernet port to track for print errors on the labels, read barcode information, or for detecting label misplacement. The Insight Vision system can be configured using Cognex's Easy Builder software to locate and identify each label as it passes by. A trigger can be set up independently to use function block code within the PLC or direct constant communication, quote, implicit messaging, using MC protocol. Take note that the direct Ethernet communication to the Q170 MCPU is supported with newer firmware versions of the Q170 MCPU only. The GT1555 HMI can be connected with an RS-232 serial connection to the Q170 MCPU to provide easy access to the controller's memory. Not only does the Mitsubishi HMI include built-in features to monitor the motion controller and servo axes, but it also allows an operator to conveniently connect via USB to program the entire controller. A CF card can be used to back up the program and download to additional machines. Some sample screens have been set up to establish default machine settings, provide basic operation, to advance the web, and to teach the controller new label pitch distances. In summary, this application solution's key points can be outlined as follows. 1. Flexible mark detection programming allows for fast and easy implementation in the software, reducing machine setup time. 2. Servo auto-tuning with the MRJ3B safety type servo amplifiers improves the machine's overall equipment effectiveness. 3. Web advance and changeover functions help save time in setting up a program that will improve machine throughput and reduce setup time. Alternative solutions include the MR-MQ100 single-axis motion controller, which is a strong solution for machines with fewer axes. Since mark registration inputs are built into the MR-MQ100, it is a good choice for labeling machines. For multi-head labeling machines with 5 or more label heads, it's convenient to standardize on a fully rack-based solution, going with the Q172D or Q173D CPUs. Another option for controlling the VFD is through a CC-Link master module in the rack. This allows for easy parameter control through a very robust and reliable CC-Link network. For further information on the Mitsubishi Electric solution for labeling machines, material can be found in 5 separate components: a double-page quick reference guide, a detailed application note, complete programming files, images and movies, and this presentation. All of this material is available on the MEAU website at www.meau.com. Just click on the Industry Solutions link to find your way to the material. And that brings me to the end of this Application Solutions webinar. I would like to thank you for taking the time to listen to this presentation.